Hey everyone, welcome to our lesson on normal distributions. When we talk about a normal distribution, we're talking about one that has a nice symmetrical shape where most of the data is in the middle, centered around the mean. And when you know that your data is distributed normally, you can guarantee that you will have these percentages each time. 68% of your data will fall within one standard deviation from your mean on both sides. 95% will fall within two, so if you travel out another standard deviation both sides from your mean, 95% of your data should be within that interval. And then 99.7% of the data will fall within three standard deviations from your mean on both sides. So now we're going to take a look at that visually. Okay? Here is a picture of the normal curve with the percentages laid out. You can see our range here that is within one standard deviation of the mean that contains that 68% of our data. Here's our second interval traveling out two standard deviations in both directions from our mean right here. That's 95%. And then here's our 99.7% interval here. Three standard deviations away from the mean on both sides. And what that means is just most of your data is going to be centered around your mean, and as you travel out away from the mean, less and less of your data is seen there. So very few out here in the tails of this curve. Past that point may be like your outliers. So we're going to look at an actual example that involves a normal curve, something that we may be asked to do involving the normal curve. So I have a problem here, and suppose we are given the mean value, and we can see that that's 20 in this problem, and a standard deviation of 5. So some set of data has a mean of 20 and a standard deviation of 5. And suppose we're asked to find a couple of intervals of percentages. What percent of data falls below 10? So we'll look for that. And then what percent of data falls between 20 and 35? So we're going to answer each of these questions. But first we have to label our picture. So what you want to do when you have your information is go down and label your mean in the center and then travel out in increments of your standard deviation. So we've got 20 in the middle here, and I'm going to travel out by 5s to the right and also to the left. Okay? So once we have that, we're going to draw in our curve. And we're going to actually label each individual percentage that will fall in each of these intervals of numbers. So from the previous slide, you could see the total breakdown of percentages. If you need to refer back to that, you can. We're going to fill those in. So we had each of these being 34 because that middle section has to make up our 68%. And then we're going to travel out and label all of these. The next ones were 13.5. And then 2.15. These are percentages under the curve here. And then 0.13 out here in the ends. 0.13%. And the good thing about these percentages is they never change. They will always be the same under a normal curve. So if you memorize them, then you'll have them for each future use. All right, so first question was, what percentage of data is going to fall below our value of 10? So let's find that area here. So here's our 10. So we're looking below that. So all we have to do now is add up the percentages that occur below 10. So we're going to add up 0.13% plus 2.15% and get roughly 2.28%. Okay. So we've answered that one. And it also asks us to find the percentage of data between 20 and 35. So you locate those on your picture. 20, here's 35, and we're just going to add the ones in between because we'd like to know about between this interval. So we got 34, 13.5, 2.15, and all of those percentages are going to give me around 49.65%. And this is how you'll approach every time. You'll just figure out the interval that they're asking about and add up those sections. Now, sometimes you will be asked to do this and your intervals that they ask you about will not fall exactly on an increment of standard deviation. Okay, for instance, they could have asked me to find the percentage of data between 20 and 23. And you can see that I don't have a label for 23, so we're going to show you how to handle those as well. Okay, when you come across that situation, when you cannot simply add up the percentages under a curve, you're going to want to use what's called a z-score. And you can actually use this every time. You don't have to use the method of adding up percentages under the curve. This will work every time, but definitely for those situations where you're unable to do it using the curve. All right, so a z-score is found by taking your value, your x value that you were being asked about, minus the mean, you can see the mean right here, divided by the standard deviation. All right, so remember that formula, value minus the mean over the standard deviation. Okay, and there are three methods. Sometimes you'll be asked to find the percentage below a certain value. So you'll follow the formula that you just saw, the z-score formula. You will take your z-score to a standard normal table, and you will just use the number given by the table. So that's for less than. Okay. Sometimes we'll be asked about a percentage greater than a value. Okay. When that happens, we're going to use that formula again. No change there, but then once we've taken it to the normal table, we're going to have to use 1 minus what we see in the table. Okay, so the standard normal table, which you'll see in a minute, gives you a lot of percentages, and you'll take 1 minus the percentage that you find, or the probability that you find. And then you may also be asked to find a certain probability or percent between. And when that happens, you're going to have to use the z-score formula twice. You're going to use it for the high value and then use it for the low value. Take them both to the standard normal table and find the difference in the two numbers. Okay, so there's your three methods if you need to refer back to those. Okay, so we're going to practice, and we're going to figure out which one we need to use and finish out the problem. All right, suppose a group of students has a mean or average age of 15 and a standard deviation of 0.7. Okay, and suppose that the ages are distributed normally. So if they tell us it's distributed normally, I can use one of these methods. All right, and we're going to find the probability that a student in this group will be younger than 14. So think about that word younger than. We are looking for students that are less than age 14. So we're going to use that first method where we go to the table and pull the number exactly like we see it from the table. Okay. So remember our formula for the z-score is to find value minus the mean divided by standard deviation. So our value that we were looking at is 14, age 14. Our mean was 15, and our standard deviation was 0.7. Okay. This is going to give us -1 in the numerator divided by 0.7, which is going to give us around -1.43. Okay, and this is my z-score. So now I'm going to take this to a standard normal table and find the matching probability. All right, so -1.43. Okay, so here's a part of a standard normal table. You may be given a standard normal table with more values, and certainly the more the better, but the piece that we're going to need is in this little snippet of the normal table, so we're just looking at a portion of it. -1.43 was our value. Okay. So what we're going to do is we're going to find the whole number part on the left side, and that's here, -1. And then we're going to round our decimal, since all we can see are the tenth spots up top. We're going to round to the nearest tenth, so this would be 0.4, which is here. And we're going to meet these two until they meet in the middle. And And we can see they're meeting here at this value, 0.0808. Okay, so that is the probability that a student is going to be younger than 14. We just found the probability. Now, if you need that converted to a percentage, what you will do is move your decimal over 2 spots to the right, and that will give you the percentage that matches this probability. 8.08% is the probability that a student will be younger than 14 in our group, according to the information they gave us. So this is going to conclude our lesson on normal distributions.